Welcome to the video tutorial for pages 4, 5, and 6 in the homework packet for Unit 1. This was the class that was Tuesday the 30th for Red Day and Wednesday the 31st for Blue Days. So the first thing we did in class today was learn about isotopes. So isotope means a different form. It has to have the same number of protons. It's going to have a different number of neutrons. So specifically, these are called isotopic notations. It's how we write isotopes. Krypton 86. Because it's krypton, we know the atomic number by looking at the periodic table. I'm just going to zoom out here a second because I think that will help us to get this on there. But krypton on the periodic table is number 36. This decimal number, remember, is the atomic mass, or the average atomic mass. So on average, most kryptons weigh 83.798. But this actual atom of krypton that we are talking about, or sample of krypton, has a mass of 86. So when you see this number written, that's just the mass number. Alright? So the atomic mass is going to be the decimal number off of our periodic table, which we said was 83.798, and then our mass number, 86. It's also written like this sometimes, where you have an 86 written up top as the mass number, and the bottom number is 36. Now the bottom number, 36, is also written on the periodic table. That's the atomic number. A equals P equals E is ape man. So A equals P equals E. 36 and 36. Now in order to find neutrons, we say mass minus atomic equals neutrons. M minus A equals N. So 86 minus 36 is 50. And we did this one together in class, which is why I did it so quickly here. But I'd like to show you number 5, because that's one we did not do together in class. The only thing they told us about number 5 is the atomic number and the neutrons. And that's all we need to know. Because remember, A equals P equals E. Ape man. So atomic number equals protons. So if this number is 54, then protons is 54, because that is two ways of saying the same thing. The atomic number is the number of protons. Now for a neutral element, which this is, if I have 54 positive protons, I need 54 negative electrons to cancel them out. So that's why P equals E. So we're getting there. Now the other thing they told me here is my neutrons. Remember, our nucleus contains all of the mass of the atom. So my mass is all in the nucleus. And the nucleus is made of protons and neutrons. So these plus these is going to give me my mass. You are more than welcome and flatly encouraged to use a calculator. 54 plus 82 equals 136. So there's my mass, 136, my mass number. Alright? Protons plus neutrons make up the mass of an atom. So my total is 136. Now to find out what element I have, I need to look up the atomic number. Number 54 is over here, xenon. Whoops, sorry about that. Xenon, X-E-N-O-N. X-E-N-O-N. Now I also need to put dash and the mass number. Just like here I put krypton 86 because the mass is 86. So if my mass is 136, I'm going to say xenon 136. The symbol for xenon is Xe. And again, I'm going to write this just like the samples they gave me above, with the mass number written above, mass, protons plus neutrons, and the atomic number written below, which is just protons. In order to find this decimal number, the atomic mass, I'm going to look on the periodic table, 131.294. So that's how you should be doing this. We did several of the others in class, so hopefully this video tutorial finished it up for y'all. Okay, let's look at number 9. We did these other two in class, so let's make sure we're looking at number 9. It says lead 206. I know this is an isotope because they told me the elements and the mass. So lead 206 is a result of a certain nuclear reaction. How many neutrons does it have, and how many electrons? Okay, neither answer is 206. This 206 tells me the mass number, okay? And mass is protons plus neutrons. So how do I find out how many protons it has first? Because in order to find out how many neutrons, I need to know how many protons. Well, I can find lead on the periodic table. It's kind of hard to find because its symbol is Pb, because that's the letters it starts with in Latin. It's a pain in the butt, I know. But lead is number 82 on the periodic table, which means, and I'm just going to write this in the margin, that it has 82 protons. That's not one of the questions they asked me. But remember, A equals P equals E. If I have 82 protons, I have to have 82 electrons. 82 positives means 82 negatives to cancel it out. So now that I know the mass and the atomic number, I can find neutrons, because mass minus atomic equals neutrons. Ape, man. So I can say 206 minus 82 equals 124 neutrons. Okay. So the nucleus of this lead, weighs 206. 82 of that is from a proton, and 124 of it are from neutrons. All right. Number 10 I love because this multiple choice format is what your test will look like. Determine the ones that don't match. Okay, eliminate the ones that don't match. All right. So if we're looking at potassium 40, potassium, in order to be potassium, has to have 19 protons. If you have 20 protons, you're calcium. A lot of students have been saying 40 on this. That's zirconium. There's no such thing as zirconium or potassium 40 or potassium with 40 protons. So potassium has to have 19 protons. That's the easiest one. So 19 protons, 19 protons, 19 protons. This one can go. That's not our right answer. Now remember our ape. Protons equal electrons. So 19 and 19 is fine. 19 and 21, that's not our answer. 19 and 19. So that leaves me possibly B and possibly D as our answers. The difference is the 40 and the 21. Now the key to this is remembering that this number represents the mass number. Okay? So this number is the total of all protons plus all neutrons, which means it's not 40 neutrons. Okay? It'd be 21 neutrons, D. 19 protons plus 21 neutrons equals 40, which is the mass. That's what we should be doing. Number 11, cross an X through the image that is oxygen 16. In order to be oxygen, you have to have 6 protons. 16 protons is sulfur, that's not oxygen. 10 protons is, let me look that up, neon, that's not oxygen. Okay? Whoopsie, I'm so sorry guys, my computer's acting up on me. Alright, 9 protons, that would be fluorine. So this, I'm going to circle it. I know it says to put an X through it, so I'll do both. 8 protons plus 8 neutrons, that's 16 is the mass, oxygen 16. Alright, so that's what we did for isotopes. Page 5, go over here. This is the Bohr models. We did aluminum in class, so let's take a look at nitrogen. Remember, the first thing we're always going to do for Bohr models is to draw the nucleus. And the nucleus contains protons and neutrons. Alright, I'm going to go ahead and grab a different color ink. Sorry if my writing in red has been bugging you. But nitrogen, how do I know how many protons nitrogen has? Remember, protons is the atomic number. So nitrogen has 7 protons. So I'm going to go ahead and label 7 protons in there. And how many neutrons? Well, on average, the average atom, the average atomic mass is 14.007. So most nitrogen have 14 as their mass. So total, this nucleus needs to weigh 14. If 7 of it is protons, then 7 of them have to be neutrons. 7 plus 7, this nucleus now weighs 14. The second step is to figure out how many electrons you need. If I have 7 positive protons, I need 7 negative electrons. Then we draw the first ring. The first ring can hold 2 electrons, so I'm going to draw those first 2 together. But I still need 5 more electrons to get to 7. So I'm going to draw the second energy level. The second energy level can hold 8 electrons, but I don't need to put 8 more electrons on there, because I already have 1, 2 here. So I'm going to do 2 more like this. Alright. Now if I go in and count, I put 5 on the outside. 1, 2, 3, 4, 5. And I have 2 on the inside. 6, 7. So there's 6 electrons. Now you can always check your answer, and please do this. This is such a wonderful trick that we've learned on the periodic table. That nitrogen is in family 15 or 5A, which means it should have 5 valence electrons. So on the outside, 1, 2, 3, 4, 5. Perfect. And nitrogen is in period 2, so it should have 2 energy levels. 1, 2. Perfect. You got it. You won't actually be drawing Bohr models on the period or on the exam. We'll be having questions more like this, where it's identify the element. So let's look here at number 12. How would I know what element this is? Remember, the identity of an element depends on the number of protons, the atomic number. So number 11 on the periodic table is sodium, Na. So I'm going to go ahead and write Na there. Looking down here at the bottom, Lewis dot structures. Let's take a look at this one. We need to count up valence electrons. There is no element X on the periodic table. It's just a variable, meaning it can be anything. But valence electrons, we've got 1, 2 valence electrons, which means that's from family 2A. So I'm going to call it family 2 or 2A. Remember, the A's, 1 valence electron, 2. 13 or 3A is 3, 4, 5, 6, 7, 8. My B's, we won't ask you, okay, because they're bad boys. They break the rules. These are the transition metals. Family 2 has a special name, and that would be the alkali, A-L-K-A-L-I-N-E, alkaline earth metals. That was from day 2. You need to have that memorized. Drawing Lewis dot structures, let's look at sodium, which is nitrogen, because that's what we did above, and it helps make it interesting. The only thing we need to know for Lewis dot structures would be valence electrons. So you draw the symbol, and then we need to figure out how many valence electrons it has. So every single element in this family will have the same dot structure, because they all have 5 valence electrons. Remember, the first bedroom holds mom and dad. They share a room, unless dad got in trouble. And then each kid wants their own bedroom. So we're going to go 1, 2 together, 3, 4, 5 in their own bedrooms. Then if we added more, we could start putting them here. But that's what nitrogen would look like. Okay. Turn to our last page of homework, page 6. The homework on page 6 is very much from days 1, 2, and 3. Not a ton of it is from today. There are a few things I want to point out to you. This NMH thing, I'm telling my students, go ahead and cross that out. Non-metal, that's a halogen. That's redundant for this one. It's the same thing. So you're just looking on your periodic table to figure this out. So number 1, neon right here, is in family 18. Hopefully by now you have memorized that this family are the noble gases. It's a noble gas, so you put Ng. Or capital N, capital G, either way. Alright, phosphorus right here in this one. We don't know this special family name for phosphorus. It's called the nitrogen family. That's not a choice. So phosphorus isn't a metal, because these ones are the metals over here. Alright. It is a nonmetal though, so I'm going to put Nm for nonmetal. It's not a halogen, because these are the halogens. It's not a metalloid, because the metalloids touch the dark line. Okay, they touch the dark line right here. And it's not a noble gas, because these are the noble gases. So phosphorus, nonmetal would be the best answer there. Go ahead and fill those all in. Alright. Taking a look at this stuff, they give you a reminder here. I would almost say cover that up. I hope by day 4 we kind of have this memorized. That potassium is in group, and we would look that one up. Potassium's K right here. It's in group 1, and it's in period 4. Okay. So I'm going to say group 1 for potassium, period 4, which means it has 1 valence electron and 4 energy levels. Something that's interesting to note is number 17. You're going to need to put an X through this box, and I'll explain why. So group 11, period 4. Let's find it. Group 11 would be this group right here. Period 4 would be this one right here. So right there, copper is that 411. Now copper is a transition metal, and the B's break the rules. We don't know their valence electrons. So this is just kind of a bad question. We should have printed an X on this box. So go ahead and write copper, C-O-P-P-E-R. You already know it's in group 11, but you don't know how many valence electrons it has. So you can cross it out or write TM for transition metal. But we do still know that because it's in the 4th period, it has 4 energy levels. One more thing you're going to notice is that even though this one says sodium here, one of these other answers is sodium, and that's just fine. There's 2 sodiums on there. Just trying to make sure you know how to do it both ways. All right. If you need more help on this, please come in, please email, do what you need to, but I hope that this will be a great start for y'all to be finishing up your homework. Thanks so much.